11.8 shows you some practical ways that probability is used. And I like to teach it sooner than later because these problems take a little bit of a process. And I've learned that if my students see it a little earlier, they just need a little bit of time to practice these problems before they get to the test. I used to teach it in order and at the end of the chapter, and then students will only have like a couple days to really practice the problems before they had to test on it. And so I found that, you know, when you guys have a little bit more time to practice it, they seem a little complicated at first, but you'll see that there's a pattern to these problems. And you just need time to practice that pattern, and then it becomes a little bit easier to follow. All right, so expected value. Let's see what that means. Okay, so expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. And you're going to see some examples of where people might use this in the business world and so on. Oh, sorry. Okay, everybody get those fill in the blanks? Okay, for example, we can use expected value to find the outcome of the roll of a fair die. Now, this is actually not the most practical use of expected value, but I show you this example because the numbers are small and easy, and it's easy to follow, what you're doing with the process. But the outcomes are 1, 2, 3, 4, 5, and 6, right? When you roll a die, you could get a 1, 2, 3, 4, 5, or 6. And each of them have a probability of 1/6. So the probability of rolling a 3 is 1 out of 6. Probability of rolling a 5 is 1 over 6. So the expected value, which we're going to capitalize as letter E, is computed by multiplying each outcome by its probability and then adding these products. So that is actually, that's how you find expected value right there, that second sentence. Multiplying each outcome by its probability and then adding these products. Now, I have organized the information in chart because I feel if you just learn the format of the chart, it helps you to organize your numbers and what you're supposed to do with them. So the first thing I've done is I've drawn this chart. The first column is outcome, and then the second column is the probability of each of those outcomes. Now, in most of the problems that you're going to do in the homework, the outcomes are not going to have the same probability. It just worked out that way because of the fact that we're rolling a die. All right, so look back at that last sentence. It says the expected value is computed by multiplying each outcome by its probability and then adding these products together. So here is where I'll actually make a third column for products, because what I'm going to do is I'm going to multiply each of these numbers in each row, and I'm going to write my answer in the third column. So the PowerPoint's actually going to demonstrate this for you. Okay, so we're multiplying each of these rows together. So 1 times 1, 6, 2 times 1, 6, 3 times 1, 6, and so on. And it's actually best to keep them in the form of a fraction because you're then going to be adding these. And it's actually better if you don't reduce because you want a common denominator when you're adding. So when we multiply it all together, here's what it equals. We get 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So now the very last thing to do is to take this third column and add all these numbers together. So to write a total at the bottom of that column. Okay, so when you total it all up, you get 21 over 6. And now at this point, you want to convert this to a decimal. So the expected value is 3.5. Now, the one flaw that I see in this chapter is that they call expected value capital E. And we had already defined capital E in 11.4 as the experiment. The probability of E is what we talked about before. So these two E's are not the same thing. I wish they'd called it EV or something for expected value, but that's what it is. Now, this is what it means, is that over the long run, you will have on average a 3.5 when you roll the die over and over and over and over and over again. Okay, so again, it ended up somewhere in the middle because all these outcomes have the same exact probability. If they didn't have the same exact probability, you wouldn't get somewhere in the middle. Now, let's see a little bit more practical way of using expected value. One way to bet in roulette is to place $1 on a single number. Okay, so down in the bottom is what roulette looks like if you're not familiar. You, the person in charge spins the wheel, they roll a little white ball around, and wherever it lands, you don't know, you have to wait for the outcome. Okay? So if the ball lands on the number that you bet on, you are awarded $35, and you get to keep the dollar that you paid to play the game. If the ball lands on any one of the other 37 slots, you are awarded nothing, and the dollar you bet is collected. Okay, now, not every roulette table lets you bet $1. Most of them actually, you have to bet a lot more money than that, so just keep that in mind. But we're using $1 to make it a little more simple here. Okay, so to find the expected value here, we want to know what will happen over the long run, but this time we're more concerned about our money. Okay, how much are we expected to win or how much are we expected to lose when we bet on a roulette game? So, okay, so here's the question. Find the expected value for playing roulette if you bet $1 on the number 20. Let's say 20 is your favorite number. And so you bet $1 every single time on 20, hoping that it's going to hit. And then you're going to describe what this means. So the first thing you need to do is make that chart. Outcome, and I'm going to add one more column to it. So we're going to have outcome, gain or loss, and probability. And then there's also, you can also make your fourth column for products, if you wish, on there. All right, so you bet $1 on the number 20. What could possibly happen? Okay, I heard you could win or you could lose. Right, so there are two outcomes in this. It can either land on 20 or not land on 20. Okay, so land on 20 or you win. Not land on 20 and you lose. Okay, so if you win, what is your gain or loss? Say that again? No, $35. Okay, this is where it's helpful to have the handout. Okay, so the handout reminds you of what was in the problem there. You guys that have the handout have the information. So you win $35. Now it says that you get your dollar back, but that's not a gain. Okay, so you get your dollar. That's what you started with. When you get your dollar back, you break even. Okay, so you gain $35. So we're going to list that as a positive number because it's a gain. Now what happens if it doesn't land on 20? You lose $1. Now since this is a loss, we're going to note that as a negative number. So negative $1. Okay, what is the probability of landing on 20? One out of 38 is correct. Good. You had to read the problem carefully because it says it could either land on 20 or any of the other 37 slots. So how many total possible outcomes are there? 38. So there's only 120 on there out of 38. So what's the probability that you don't land on 20? 37 out of 38, right, because there are 37 slots that are not the number 20 out of a total of 38 possible outcomes. Okay, so we filled in our chart, and now we're really just concerned about our money. What's going to happen with, how much would we win over the long run, or how much will we lose over the long run if we continue with this particular strategy? So I actually don't need this outcome column anymore. I am now going to multiply the gain or loss with the probability. So multiplying across. So, and you know what, I'm just going to leave it in the form of a fraction because I'm going to be adding these numbers anyway. It'll give me a common denominator. So 35 times 1 over 38 is 35 over 38. And then negative 1 times this fraction just gives you the fraction negative. So negative 37 over 38. Okay, add these two numbers together. They already have a common denominator of 38. And so 35 and a negative 37 is negative 2. At this point, this is where you change that number to a decimal. Okay, everybody follow so far on what's in the chart. It's going to disappear for just a moment because I also have it typed in here, so just give me 1 second. Okay, so this is essentially what we did. I just didn't show it in the fourth column. Is 35 times 1 over 38 and negative 1 times 37 over 38, which gives us negative 2 over 38, which is the same as negative 0.05. Now remember that this was money that we were multiplying by, so it's negative 5 cents. So this is what this means. Over the long run, you cannot predict what will happen in the short run. But over the long run, if you always do the same thing, you bet on 20, 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 you're going to lose, 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 maybe win once. Then lose, 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 maybe win again, okay? And over the long run, you will lose about 5 cents per every game played. So roulette is not a winning game. It's a lucky game. It's not, it's not something that is known for something you win at all the time. But it all depends on whether this is worth the risk, okay? Maybe you just really enjoy it and you can afford to lose about 5 cents a game every so often. It's just like going to the movies. Okay, you go to the movies, you spend, what, 20 bucks after you pay for your ticket and, and a drink. And you don't get that 20 bucks back, right? But you're going to the movie to enjoy the movie because it's what you like to do. So you already know ahead of time that, yes, you can afford to spend that 20 bucks on there. So again, this is just, something that, you could, that someone might use to figure out, well, is this something worth the risk for me to do in the long run? Now again, remember that most places will not let you just bet $1 on roulette. You have to bet a lot more money, which means you will lose a lot more money per game in reality. Okay?